Hello everyone and welcome back to another video. In this video I want to talk a little bit more about bitmaps, and if we go back to the Write a Database from Scratch series, you can see that in episode 10 I have talked about bitmaps, which is what we use to store non-unique indexes. In the bitmaps section of this video right here, you can see that I will explain how we can use a byte array and assign each bit of the byte array to the nth row of our table or the cluster ID. And while things can actually work like this, during the implementation, I realized things are a little bit different. So let's come back to our Blackboard here. And we're gonna assume that we have an empty bitmap, which looks like this. And as you can see, our bitmap has 2 bytes. So let's write it down here. Now let's say that we want to store the number 0 here. And the question is, which bit should be swapped in this case? I know that as we previously discussed, maybe we would never need to store number 0 in the bitmap because our cluster ID starts with 1. But for the sake of our example, we allow the bitmaps to store number 0 as well. If we take a look back, we said that for cluster ID 1 here, we changed the first bit in the bitmap. And as I have said in the beginning of this video, this solution can work, but this isn't how I have implemented the bitmap. So you can pause the video here and think about where would you store the 0 before I start to explain things. Before we move on to 0, let's change our example first. Let's say we want to store the value 9. With our previous approach, this would be the 8th bit and this would be the 9th. But when we actually want to start working with this byte array, how do we know which byte to work with? Or how do we know that we should change the value in this byte and not this one? So whenever we want to store the number n, the byte index that we want to manipulate would be n divided by 8. And of course, we want the ceiling of that and not a float. So in this case, the ceiling of 9 divided by 8 would be 1. And then to know which bit we should swap, we will use n mod 8 to find the index of the bit. And in case of 9, that number would be 1. So again, note that these are indexes and indexes support 0. So the byte index 1 is this byte right here, but where is the bit index 1? So normally if you have a byte like this, and someone tells you to swap the first bit, you wouldn't start from here. You start from here. And the index of this bit is actually 0, not 1. This is the first bit, but the index is 0. And here we're talking about bit index. So the bit that we should flip to store number 9 is this one. Now let's say that we want to store number 8. Again, using the same algorithm, the byte index would be 1 and the bit index would be 0. So the bit that we should swap in this case is this one. And using this approach, we will see that if we want to store number 0, the byte index would be 0 and the bit index would also be 0. So the bit that we should swap is this one. Now, using this approach, if we want to extract or iterate over all of the numbers that are stored in our bitmap, all we have to do is to go ahead byte by byte and then check the nth bit of that byte using the same rules as mentioned here. Now, if we take a look at the code of my bitmap class, you can see that it's generic and the keys that we store in the bitmap should be a number. There is a problem with this and I will explain it later on. And due to that problem, which is unnecessary, I had to convert the key into a big integer. So whenever we want to fill up on the bit, we ensure that the bitmap has a capacity and we will grow the byte array if we need to. And after that, as I've already explained, we will find the byte index and bit position. And this is how we can flip the end bit of that byte in the byte array. And if we want to flip the bit off, then here we have almost the same logic, except our bitwise operation is AND operation instead of OR. And we don't actually need to ensure the capacity. If the size of the byte array is smaller than the bit index that we need, then we consider that the bit is already off. We don't need to expand the byte array. And at last, understand why I have converted the generic number in the bitmap. I want to mention that I have talked about a cluster ID, and you can go back to episode 10 to understand what is the cluster ID and why we are using it. And in that case, I said that I'm thinking that the cluster ID in my database implementation is probably going to be unsigned or positive long. But during the implementation of the bitmap, I realized that it's going to cause some problems for me. And that's because in that case, these bitmaps should grow to support bit numbers as large as maximum unsigned long. And that would cause problems because any Java array can be only as large as maximum integer value. So I should either implement my own byte buffer, which can concatenate multiple byte arrays together, or I should just keep things simple right now and only use positive integers as cluster ID.